Hello friends, welcome to EC Academy. In this lecture, let us understand a problem on star delta transformation for an AC circuit. Here, we need to obtain the single delta connected equivalent circuit of the network shown below. So for this network, we need to convert into a single delta connection. As it is seen from the circuit diagram, the three resistors 10 ohm, 10 ohm and 5 ohm are connected in a star at point B, and J10 ohm, J10 ohm and J5 ohm are connected as a star at point D. Now these two star networks can be replaced by an equivalent delta network. Now let us consider the first star network 10 ohm, 10 ohm and 5 ohm, and let us convert it into the delta network. So this is the star network at point B. So now we need to find the resistance between AC, the resistance between CM and the resistance between AM to convert it into a delta network. Now to find the resistance between A and C, we can multiply these individual resistances and we can divide it by the resistance 5 ohm. Therefore, RAC is equal to 10 into 10 plus 10 into 5 plus 5 into 10 whole divided by 5 ohm. So it will be equal to 40 ohm. So the resistance RAC is equal to 40 ohm. Similarly, let us find the resistance between A and M. So the numerator will remain same, and at the denominator it should be the opposite resistance. So the opposite resistance between A and M is 10 ohm. So we can say RAM will be equal to, the numerator will remain same. So the numerator value is 200 divided by denominator is 10 ohm. So it will be equal to 20 ohm. So RAM is equal to 20 ohm. Now let us find the resistance between M and C. So we can find RCM is equal to, numerator will be equal to 200 divided by, so the opposite resistance between C and M is 10 ohm. So we can write 200 divided by 10, that will be equal to 20 ohm. So we got all the resistance value. Now let us convert this into a delta network. So this is the equivalent delta network where RAC is equal to 40 ohm, RAM will be equal to 20 ohm, and RCM is equal to 20 ohm. So in this circuit, we can replace this star network at point B with this delta network, and we can redraw the circuit. So the given circuit reduces as shown in this figure. So the star network between point B is converted into delta network, and we have redrawn the circuit. Now let us consider the star network at point D. Let us convert it into the delta network. Now let us find equivalent inductance between each point to convert it into the delta network. So the inductance between A and C can be written as J10 multiplied with J10 plus J10 multiplied with J5 plus J5 multiplied with J10 whole divided by, since we are finding the inductance between A and C, the inductance in the opposite side of A and C is J5. So we need to divide it by J5. So in the denominator, it will be J5. So if we simplify this, we'll get minus 200 in the numerator divided by J5. So we can take this J to the numerator and we can write minus 200 into minus J divided by 5. So it will be equal to J40. So The inductance between A and C is J40. Similarly, we can find the inductance between A and M. The inductance will be, the numerator will remain same, minus 200 divided by, since we are finding the inductance between A and M, the inductance at the opposite side is J10. So we can write J10 in the denominator. So this will be equal to minus 200 into minus J divided by 10. So it will be equal to J20. So the inductance between A and M is J20. Now the inductance between C and M is also J20 since it is having the same values. Therefore, the inductance between C and M is equal to J20. Now we can use these inductance value between A, C and M to write a delta network. So the equivalent delta network will be as shown in this figure. Now we got two delta networks. So these two delta networks can be combined and we can redraw the circuit. If we combine these two delta networks between point A, C and M, the circuit further reduces as shown in this figure. Here, if you can observe, 20 ohm and J20 ohm are in parallel between the points A and M, and 20 ohm and J20 ohm are in parallel between the points C and M. Similarly, 40 ohm and J40 ohm are in parallel between the points A and C. Now, we need to use parallel formula and we need to simplify the network. Now, between points A and M and C and M, the values are same. So, we can write the equivalent of 20 ohm and J20 ohm in parallel will be equal to 20 into J20 divided by 20 plus J20. So if you simplify this, you will get 10 plus J10 ohm. So the value 10 plus J10 ohm can be used between the points A and M and C and M. Now the equivalent of 40 ohm and J40 ohm in parallel can be written as 40 into J40 divided by 40 plus J40. So which will be equal to 20 plus J20 ohm. So the value 20 plus J20 ohm can be used between the points A and C. So if we replace the values between the points A, C and M, we'll obtain the equivalent single delta network. Finally, we have replaced the parallel values between points AC, AM and CM with the values which we have calculated. So this circuit is equivalent to single delta network for the given network in the problem. This is about problem on star delta transformation for AC network. Hope you have understood the topic. Thank you.